Okay, well, I thought I'd make another update video on the pickup truck. And by the way, if you hear music in the background, that's Abby upstairs doing her silks stuff. But you can see we're in the garage and still working on the pickup truck. So, can't remember where I left off with the last video. I installed a new differential, 411 out of a V6 4Runner, so it has the 4-pinion carrier. That ended up working out pretty well. It was a little bit rusty, but the gears were pretty solid. And I think I mentioned in the last video that turned out to work real well as far as the speedometer went. Also, I had some vibration coming through the shift lever. I tracked that down to the U-joints, as I mentioned. That's been good. And then I've been prepping the block over here. You can see I pulled the cylinder head off. I might have mentioned in one of my other videos that I was having a weird roughness. I think I tracked that down to too high compression on cylinder number 1. Talked to Tony over at LCE Engineering. We were scratching our heads as to why there would be higher compression in cylinder number 1. The only thing I can figure is that due to the firing order, 1342, I'm thinking that because cylinder 1 fires after cylinder number 2, that perhaps there was a leak across the 2 cylinders, and so as cylinder number 2 was coming up on its compression stroke, that would mean that cylinder number 1 was just getting ready to follow it. And so I'm surmising that some of the pressure from cylinder number 2 was being put over and almost like a forced induction and pre-pressurizing this cylinder slightly just prior to it coming up. That's the only thing I can figure out that would account for the higher pressure in cylinder number 1. I checked the cylinder head. There was no, unusual carbon buildup or anything like that. So that's the only thing I can figure. But as you can see, I've been getting the block cleaned up. I discovered also that it turns out someone had previously bored this over 0.5 millimeter or 20 thousandths. And so I was getting ready to pull the block out and have it bored over, but when I measured the cylinder bores for roundness and taper, pretty much perfect. So I suspect that the rebuild on this was not too long ago. You can see that there's some discoloration, but when you feel it with your fingers, there's not a lot of wear and tear. I mean, you can kind of feel a little bit, but you can't really, get your fingernail on it. It's pretty smooth. We're talking like an RA of 2 or 3 or something like that. But I figured, well, since this motor's only got to last a couple of years, I'm just going to go ahead and put it all back together and utilize the existing short block. A couple things I did is opened up the oil gallery and cleaned that out. I cleaned this area here up, cleaned this area. I broke the glaze just ever so slightly using a 3M Scotch-Brite pad. When I looked down into the water jacket area, it was really filthy. It was, it looked like a New York City gutter. No offense to the New York viewers, but you know what I'm saying. It looked like a gutter down in there with a lot of debris. And I tried a lot of different methods to clean it out. I used a chopstick. You can kind of see the remnants here. So I used a chopstick and a flashlight to fish around down in those little gutter kind of holes. What I ultimately used was this, and then I stuck the hose from the shop vac in here, and then I just dug that down into the water jacket of the block. The other thing I did that worked actually amazingly well, it resulted in the internal part of the block ending up cleaner than if you ran it through a hot tank at a machine shop. Let me see. I don't think I have my flashlight. Oh yeah, I do. Okay. But if you look down, I don't know if I can get it on camera here, but oh yeah, actually. So if you kind of look down into the water jacket area, you can see how darn clean that is down there. That was just absolutely filthy before. So like I said, the way that I cleaned it was I mixed up some distilled water with some citric acid, like what you would use. It's what I use to clean my espresso machine tank, actually. And I let it sit in here overnight, and then I came out in the morning and I vacuumed it out using that little funnel and hose affair in the shop vac. And then I flushed it a couple of times with just distilled water and sucked, you know, the water back out each time, and then used the chopstick to kind of break up a little bit of stuff. Once I got it to that point, I was just shocked how clean it was internally. And then I just went along with my air compressor and blew it out. And then I took a heat gun and, you know, kind of just blew some hot air into that water passage. So I'm really pleased with how clean that came out. You can also see I chased all these holes using a 12 millimeter bottoming tap. And that made a real big difference in how well the new head bolts threaded in. So if you're doing a 22R or 22RE motor, highly recommend that. On the deck, I just kind of cleaned it with a scouring pad a little bit, and then I took a machinist rule and a feeler gauge and checked it to make sure it was flat and everything. Using you know, a 1.5 thousandths feeler gauge, I'm unable to get in under a machinist rule. So I think the deck is in pretty good shape. So I'm going to go ahead and use it as is. And then you can kind of see over here, and then I've been prepping all the pieces and what have you. So you can kind of see over here, these are my parts from LCE Engineering. So this is the front cover gasket, front cover timing chain cover for the dual row timing chain. I like everything about it, except they're not real happy with kind of some of their, you know, chamfering of the edges. It looks like whoever did it missed. I'm assuming this comes from some other country, and so they were, you know, kind of a little bit careless there. The other thing I'm not super crazy about, and I don't know, maybe you guys can let me know if there's a reason for this, but the way, look how thin that wall is right there. I don't know if that's just mis-engineering when they designed this or what, but I'm not real thrilled about that. Functionally, it may not make a big difference, but just because I'm real detail-oriented, I'm not super thrilled about that. If you look at the factory Toyota one, you can see it has a significant amount of meat there. So I don't know what the story is there. Maybe just whoever LCE Engineering uses for their production just didn't get it right, which is kind of a shame, because otherwise this is a really beautiful front timing cover for the Toyota. So, and then I'm using the metal backed timing chain guides. Let's see what else. You know, I've got the assorted stuff that comes with these different kits from LCE. Using some break-in stuff there. And then I redid my valve train tree stuff here. You can see these are the original factory rods that the rocker arms ride on. And on the bottom side, you can see how Toyota approaches it. They have a hole and a little milled kind of groove, and the idea is that since this is on the bottom of the rocker arm where all the stress is, because you know the rocker arm is pushed up on each side, so underneath is where it gets a lot of its friction. What Toyota's done is they just milled this little kind of extra groove in there to help oil get out to the sides. What LCE Engineering offers is rods that have actually 3 holes on the bottom. I can't really show you because I've already assembled it, but it has 3 oil holes on the bottom, so that really gets the oil down. So I upgraded to that, put in new rocker arms, obviously, to go with the new camshaft. I'm running their Pro EFI cam, and you can see I haven't torqued it down. The original head from LCE Engineering comes with, you know, this kind of affair. I ordered some ARP bolts, the 12-point ones. I think they're in my office, but to hold down the cam. I also have some ARP bolts to hold down the guides and a few things, and I have some different ones for the time and chain, you know, tensioner thing. But you can kind of get an idea of the direction we're heading. This is the EFI Pro Cam, I think they call it, from LCE Engineering, and you see the dual row timing chain stuff. I was going to go with the adjustable timing chain and actually degree in the cam, you know, and make sure it's exactly right. But because this is a new head and a new cam and all new timing chain stuff, and because the block, I measured the height of the short block, and it's never been milled. It's exactly the factory Toyota height. So because everything is you know, the deck height from the surface of the head to the center of the cam is factory. Nothing's been milled. I opted to not go with the adjustable cam gear, and I'll tell you why. For one, because this is just going to be my daily driver. I don't want there to be any potential that the cam, you know, hold down stuff could slip. Also, because this is not a race motor, I'm not, you know, if I was off 1 degree on the cam plus or minus, it wouldn't be the end of the world. So I'm kind of going with simplicity over adjustability. If I was doing a motor where I was, you know, really pushing a lot of horsepower, or I wanted to vary the cam timing 1 or 2 degrees, I probably would go with the adjustable cam gear. I have run it on other motors in the past, and I like it. I like the ability to degree in the cam. But for this, for just my truck, I felt it was unnecessary. But really impressed with the cylinder head from LCE Engineering. This is the Pro head. I forget which one it is. It's about $1,100-$1,200 on their website without the cam. And then you can, it's the head. It's the most aggressive head you can run with the stock ECU, basically. And I figure when everything's all said and done, between my LC headers and the 2 1/4 inch stainless exhaust, and then the ported head, you can kind of see they did some porting in there, and then this cam and I believe it has slightly larger stainless valves. With all that, I figure I'm going to be probably go from the stock, you know, 115, 16 horsepower of the 22 RE up to, you know, 135 is probably about where I figure I'll be. So, and then I'm transferring all the titanium exhaust studs and intake manifold studs over from the old head, and I'm getting ready to assemble everything. Brand new head bolts. These aren't factory. These are original equipment, but they're by you know, another company. So I don't believe they're technically. I don't believe they're technically Toyota head bolts, but they are new. I'm not a big fan of reusing head bolts. One thing I will say is I'm real impressed with all the parts from LCE Engineering, because they are all, you know, Japanese parts. So that's good. And so just getting ready to kind of reassemble everything and get the truck back on the road. Let me see if there was anything else I wanted to touch on in this video. Oh, I guess the other thing was just head gaskets. You know, I was contemplating running a solid copper head gasket on this, but I did a little bit of research and I decided that wasn't maybe the smartest idea I ever had. I was looking into maybe using an MLS multi-layer steel head gasket. I also ultimately decided that that's not the smartest idea I ever had. And if you guys have seen my video where I inadvertently destroy my fuel gauge on the truck, you'll know I often have a lot of not good ideas. But by and large, you know, stuff works out pretty well on my project. with regard to the head gasket, I like the idea of running a copper head gasket, although in researching it online, I decided that it probably would be best to O-ring the block in a situation like that. There are some companies out there that have kind of hybrid gaskets. I ran across an interesting one. Forget the name. It's like SGC or something like that. They make the Vulcan head gasket and the Titan Pro copper head gasket, and they make a copper version that has like an integral sealing ring, and I may ultimately use that when I build my 3RZ or my 2RZ turbo motor, because it kind of brings all the benefits of an O-ringed block without having to actually O-ring the block. So it seems to be an O-ring kind of style head gasket. I believe it's copper too, but it has kind of sealing for the different passengers. So in the end, I decided to just go with the standard kind of, I think it's composite head gasket from LCE Engineering, the one that comes when you buy the cylinder head and say, yes, I want the head gasket kit. What they send you is pretty darn good. It's made by Stone, I believe, which is a Japanese company. And it kind of just looks like a Victor head gasket, or, it's kind of a full graphite head gasket. Let me see here what kind of gasket it came off the motor. Oh, and you can see also, interestingly enough, my original plastic guides, one of them had cracked. So I'm glad to be switching over to the new stuff. So this, based on what I've been searching recently, this would appear to be a factory head gasket, a factory Toyota OEM head gasket, and you can kind of see this metal interior piece. Now, on my motor, I believe the head gasket blew, so that I don't think that's anything against the factory head gasket. But one thing I'll say in my research, in reading online and studying the different things about head gaskets, is I think maybe using a factory head gasket on an old motor which hasn't been resurfaced is probably not a great idea. And here's why. When Toyota puts the motors together in the factory and they use the OEM head gasket, everything is absolutely perfect. And granted, my cylinder head is perfect on the surface, but my block isn't. So if you look, you can kind of see the situation here. There's a little bit of, I guess you would say like micro pitting or something here. I mean, you can't, like if you run your finger over it, and I don't have a profile meter, which is it's a meter. It's a fairly expensive meter, a couple $1,000, but it allows you to get a surface RA, roughness average. You can kind of figure out where you are with your fingernail. Obviously, it's not as scientific as using a roughness surface meter. The surface here is not real rough, but you can see it has some discoloration. But it's mainly discoloration, it's not like you can't feel even, I would say like even half a thousand. There's not even half a thousandths there. So that's why I'm not too worried about the deck. But what I was getting at was when Toyota's assembling the motor in Japan, everything's absolutely perfect, and you could get away with running a multi-layer steel, an MLS head gasket, or you can use one of their, factory OEM styles, which kind of does have a little steel in there. But when you're dealing with rebuilding a motor and perhaps a less than perfect, deck mating area for the head gasket, I think it's smarter to just go with the kind of the almost generic-ish composite gaskets. And here's the reason. And let me just go in the office real quick. Okay, so if you go in here and you see this is the head gasket. Okay, so this is the company. I think it's called Stone, right? Okay, so this is the head gasket I'm going to use on the truck, and you can see it's totally a composite kind of material, and it has some O-ring sealing. So it is different than what what an OEM Toyota head gasket is. If you look closely at it, it's all this kind of composite material, and then they just have sealing rings. And here's what's good about that is in all this area, it's very cushy and spongy, and that's kind of what you want when you're dealing with an aluminum head against a cast iron block. And the reason for that is because the aluminum and the cast iron, they expand at different rates. So what I'm getting at is, because every time you drive your truck, you heat up the motor and that cools down, and the expansion coefficient, I guess you'd say, or ratio of cast iron versus aluminum is different. Just like when you run forged pistons, they kind of in the morning, they kind of clatter a little bit because they haven't expanded enough. Well, it's kind of the same thing when you're dealing with cast iron versus aluminum. So you get this kind of, you've got the cylinder head up here and the cast iron block down here, and they're expanding and contracting and due to heat at different temperatures. And you end up with, what happens is you end up with kind of almost like a scrubbing effect on the head gasket. And so that's why I'm not a big fan, even when you have a perfect block, of using an MLS head gasket. Yeah, some companies like Fel-pro have that, I can't remember what they call it. It's like a Perma Torque or something like that, where they have their own composite, I think it's like a sealer of some kind, and then that's supposed to bond to the surfaces. I'm not a huge fan of that, just like I'm not a huge fan of using copper coat. Like when I was 18 or 19 building motors, I would spray copper coat all over my gaskets. But as a 55-year-old, I'm not a big fan of that anymore. So what I'm getting at is that composite kind of graphite-y material that is all around out here on that O-stone or stone gasket or whatever is from Japan. That is like a little cushiony material that helps with that expansion difference between cast iron and aluminum. So that's why I'm going with that gasket. And I think on a block that's got some miles on it, even though the surface finish is pretty good, I think you're going to get more miles down the road using that type of head gasket and then torquing the bolts down than going with some of these more advanced modern things when you're dealing with a 1990s sort of cast iron block. So that's my 2 cents on the subject. Whether I'm right or wrong, I don't know. I'll check back in 200,000 miles and see if my head gasket is blown. But that's kind of the direction I'm heading. So I think that's probably about it on the update for the truck. If I think of anything else, maybe I'll toss in the description section. But trying to get this guy back on the road here, and like I say, I'm just gonna go with what I have. I think my rings are okay based on the compression readings I was getting from the before I pulled the head off, and try to get this thing back together. So hopefully you guys have enjoyed the video, some of the information. I've had it here. The only other thing I say is I wanted to use the ARP studs, but everybody was sold out of them. I called and talked to the engineers at ARP, and they said that they were making a change to the kit for the Toyota 22R. So I don't know if that means the old studs, there was something they needed to change, or if they're just using the opportunity currently to change things. But unfortunately, they're not available till April or May, and I got to get out of here and head down south, so I don't have time to wait around. I am an advocate of always using new head bolts, even though a lot of people say you can reuse the head bolts on the Toyota. I like to just use new head bolts every single time on motors. One thing I will say is I'm going to torque them down, instead of to the factory 58 foot-pounds. I'm actually going to go to 60, somewhere between 63 and 65, probably 65 foot-pounds, maybe 63 foot-pounds. And then at 500 miles and maybe 1,500 miles, I'm going to re-torque them to probably 65 foot-pounds. So I think that's probably a good way to go. On the ARP head bolts, they do them up, something crazy like 90 foot-pounds. But keep in mind that when you get into using those kinds of torques, you actually can distort by pulling. You can actually distort the cylinders a little bit. So you got to be careful of that. And that's why you see on high performance motors that use, particularly when they use studs, you'll see them boring the block using a torque plate, torqued to whatever the final torque is. I sincerely doubt this block was bored with a torque plate or anything exotic like that. So I'm just going to stick with the factory specs and add a little bit of extra torque on the bolts. But you got to be careful. Don't go crazy with your head bolt torques, because you can actually distort the block and cause more problems than you're solving. So, all right. So I guess that's everything I can add today. Like I said, looking forward to getting the truck back together. Wanted to do an update video. Should have things running pretty soon. Going to break in the cam using some oil additive that has some zinc in it. And then hopefully we'll be back on the road. So as always, thanks for watching. If you guys have any comments, feel free to use the section below.